Okay, for this video, we'll be discussing about basic research designs. So primarily, as a researchers, you need to determine what design you would need in order to really best answer your research question. Okay, so let's have this example. Let's say that you have this research question. What is the effect of setting up a computer laboratory, with internet, in a high school on the students' math scores? So you'd like to explore a possible relationship between internet in a school and the way students perform in math. Alright? So what research design would be best for you or most optimal? So there are a lot of things to consider in choosing a research design. You have to select, of course, based on the research question. You also look at resources that you have in terms of your budget, in terms of your time, and of the human resources in terms of expertise, and the people who can help you do this research in terms of collecting data, doing interviews, etc. So let's go to the various examples here that I've placed it on the board. The first one would be what you call your pre-experimental designs. So the first one is what we call our case study. So this is the simplest design in terms of its structure. So you see that we have made notations here. So for example, X, okay, when when making or codifying a research design, we use these notations. So X means the intervention that you are doing, and O would refer to the observation or the point at which you collect your data or your observations. So a case study is very easy. So for example, if you want to do a case study to attempt to answer this question, what you will do is first do the intervention itself. So in this case, this is the intervention where you set up and operate your computer lab in the high school, and then after a certain period of time, let's say 1 year, after 1 year, you will do your observations. So you will interview students, for example, or look at their test scores in math, and based on that, make some certain conclusions. Obviously, if you look at this design in terms of its level of accuracy or of the level of evidence that you can collect from this, the case study is not a very good research design in this case. So let's go on to another pre-experimental that has a capability to generate a bit more evidence than a case study. It's called a one-group pre and post test. So for example, before you set up your intervention, or for example, before you institute your computer lab in school, before that, you will do a pre-test. So for example, you will gather a certain number of students, give them a pre-test, for example, in math, and get the average scores. So you will get the average scores here, and then you will now set up your computer lab, and then after a certain amount of time, you will again do now a post-test to this number of students and get their average scores, and you can now do a comparison. What was the average scores here compared to the average scores here? So for example, if the average scores here are higher after you set up the computer lab compared to the time when there was still no computer lab in that high school, you can say with a certain amount of accuracy and validity that perhaps the computer lab had something to do with that in terms of improving the math skills of your students. Some would opt for a research design called time series. So if you want to be really sure that, for example, in this design, that the increase, for example, in math scores of students is not a fluke or a one-off event, some would opt for doing a time series. So for example, if you look at this example, prior to your computer lab, you do your pre-test for your students, and then after the intervention itself, after a certain amount, for example, maybe after 1 year, you do a post-test, and then a year after that, another one, a year after that, another one, and then a year after that, another one. And then you will now compare the average scores, okay? If you see a pattern here, okay, that let's say that from continuous yearly use of the computer facilities, you will see a pattern wherein, let's say, the average scores of your students in math are steadily going up. You are more confident now that through the years, you can say that there was indeed, that the computer lab indeed had an effect on improving the math scores of your students. So this is a good way to answer a question. But again, there's also a time element that you need to consider. So this is, sometimes time series studies take a long time to complete. So let's go to a second group, which is called the pre-experimental. But now there's a separate control group. So it's like a case study wherein there is no pre-test. You just do an intervention in one area. For example, this is in one municipality. In the high school there, you set up a computer lab. And then after 1 year, you will measure, you will do a post-test on your students in terms of their average math skills. But in order to improve the level of quality of your research, what you can do is have a comparison municipality, for example. So in this municipality, there is no computer lab that was set up. And then at the same time, okay, the same time that you will do a post-test in this municipality, you will do another set of observations in this municipality. And you will see that you can determine if there's a difference. Is there a, for example, is there a significance between the post-tests of students who use computers in this municipality versus students who are not able to use computers in their school in the other municipality, right? So this is one type of comparison study. Of course, you have to really look at other issues such as ethics. So, for example, ultimately, is it ethical to say that these students really have a better chance, for example, of having high grades simply because they have computers, whereas this group of students do not have computers? So there's sometimes an ethical issue that you need to consider there. Okay? And the last group are what you call your true experimental designs. It's called true experimental because if you notice here, there's the letter R, which means that there's a level of randomization that you do, which means that when selecting the students, for example, for this study, you randomize the sample so that you reduce the bias. For example, you reduce the bias, for example, of having too many smarter students who might, artificially increase the average test scores. So you randomize it as much as you can. So for example, one example would be a pre and post test design with a control group. So it's basically like this one, the one group pre and post test, but you have two groups. So for example, you have two municipalities. In one municipality, you have your computer lab, and in this other municipality, there is no computer lab. So prior to the computer lab being set up, you will measure the average math scores of your students and compare it with the test scores of your students after they have been using the computer lab in this municipality. And you would do similar measurements or observations in this other municipality, but then the difference is in this municipality there was no intervention, or you did not have a computer lab here. So you can now compare the level of performance of your students in math compared to this municipality, and you can have a better sense of accuracy in terms of making conclusions on whether or not your intervention here really caused the effect. And finally, you have what we call your post-test only type of true experimental design with a control group. So it's sort of like a case study here, or this one, the pre-experimental. Okay, so it's basically just like this. The difference is that you randomize your samples, or you randomize the group of students that you will administer tests to. So in one municipality, there's the intervention of your computer lab, and then on another municipality, there is no intervention. So looking at these different research designs, you will see that This would be the simplest in terms of the design, and you can also say that if you are, for example, pressed for time, pressed for resources, you can opt for a case study. But be aware that in terms of the power of this research design to really capture what you want to capture in terms of answering the question, this might not be the best design. Okay, ultimately, true experimental designs are the best design in terms of the level of quality of results that you can get. But looking at how these designs are set up, this can be quite expensive. You need more people to do this, and you might need to hire extra people, for example, statisticians or really people who are experienced in research to help you do these research designs. So at the end of the day, as a researcher in ICTs, okay, you have to really select what is the best design you would think that can answer your research question.